In this video, we're going to continue solving equations and inequalities, but we're going to explore more than one inequality or equation together. We're actually going to be exploring how to solve systems and how to get a solution set from a system. So what is a system? A system is a collection of equations or inequalities that you deal with together. So what situations would require me to do this in the real world? Well, you've often heard of this example that's quite popular. If I were to leave from the same location in a plane, in a train, or in a car and go straight home, who would get there first? So each one of these situations would have to be calculated based on, of course, the velocity of a plane, the distance, the velocity of the train, traffic perhaps for the car. And so there are a lot of variables. So each situation would require its own equation. However, because this is essentially one problem, we would end up with multiple equations. Trying to find which one would be the most efficient mode of transportation, we would have to deal with the three equations together. And so that would be a great example of a system. So in this video, we're going to look at some systems. We're not going to talk about the situations or word problems that they would be in. We will just talk about how to get the solution set. X minus 4 equals 0, and we have 3x plus 6 equals 18. So if I were to solve this, I would notice that I get both answers, x equals 4. Then my solution set is only one number, and in this case it's the number 4, right? So in a graph, I would simply graph the number 4 to express that that's the solution set for both situations. Now if I'm doing an inequality, you might see situations where you have two inequalities in one. This is called a compound inequality, and it might be easier for you in the beginning to split these out. So I can split this out into two separate inequalities, 0, x is greater than 0, and x is less than 3. So if I do that, then when I'm graphing the solution set, I'm going to use the same number line. So in this case, x is greater than 0, and there's no equal sign, so I'm going to leave an open circle. And then the other part of this inequality is x is less than 3. Now in this situation, what you have is you have two solution sets that are taking you in different directions. The solution set for the system is going to be all the points in which both solution sets intersect. So in this case, I can tell that anything after the 0 and before the 3 is an area where both solution sets intersect. So for example, the number 1 and the number 2, those would be some numbers that are in the solution set. And so to graph that situation, and I'm going to take the graph out just to make it a little bit more clear. The way you would do that is simply graph both situations, but shade the area in between. You would completely ignore the arrows that are going on the opposite directions because those solution sets are not intersecting each other, therefore they cannot be part of the solution set of this system. And of course, if we're using set notation, then in this case, when x is a real number, x is greater than 0, and x is less than 3. That's an example of when you see the word and. Now there is another situation and when instead of using the word and, we would be using the word or. So let's look at these situations in here. Solve for x. So in this situation, I have one equation or the other. So either one of these answers would work for this system. So that's what or is telling us. You can either have this or the other, and that would work. So in order to graph that situation, you would use the same number line. There's my 0. there's 3, and there's 7. And you would simply graph both points. Now in set notation, you would put them in order from least to great. Now let's look at our inequalities. I'm going to go ahead and first solve them. And so what I have in this situation is I have x is less than 8. So I have my number 8 here. And with an open circle, I'm going to graph all the values to the left that are less than 8. And then I also have x is greater than 12. So I have 12 here. With an open circle, I'm going to graph and indicate with an arrow to the right all the values that are greater than 12. And that is how you would graph this. Even though they're going in two separate directions, they obviously, the solution sets of each inequality, they do not intersect. With the word or, you can have one or the other for the system to work. And then, of course, when you're using set notation,